Hello dear students, welcome to ECE Academy Benefactor. In this class we will be seeing design of a synchronous counter. The topic is from the Sequential Logic Circuit. The subject name is Digital Electronics. The given problem is design a synchronous counter which counts the states 0, 1, 2, 3 and then again it repeats 0, 1, 2, 3 and then repeats 0, 1, 2, 3 using JK flip-flops. Coming to the solution to the problem, first we need to draw the state diagram based on the given condition. So, it is counting the states 0, 1, 2, 3 and again going back to 0 and the cycle repeats 0, 1, 2, 3 back to 0. This state diagram can also be drawn in this form where 3 is the largest number and it requires 2 bits, that is 1, 1. So, we have used 2 bits for its binary representation of these decimal numbers. 0 is 00, 1 is 01, 2 is 10, 3 is 11. So, this is the state diagram of the given problem. Based on the state diagram, we need to draw the transition table. The transition table requires present state, next state and flip-flop inputs. So, how many flip-flops we require here? 2 flip-flops because 2 bits are there for representing the largest number of the state. So, the present state 2 flip-flops means 2 outputs QB, QA. The next state of QB will be QB plus 1. The next state of QA will be QA plus 1. The first column is present state, 2 flip-flops, so 2 outputs QB, QA, next state QB plus 1, QA plus 1 and these are the flip-flop inputs, third column. So, how many flip-flops we require? 2 flip-flops. One is JB, KB of the first flip-flop and JA, KA of the next flip-flop. So, we take JA, KA as the first flip-flop and JB, KB as the next flip-flop. Okay. So, we require 2 JK flip-flops, present state, next state, flip-flop inputs, QB, next state is QB plus 1. So, we need to compare QB and QB plus 1 to write this JB, KB states. How to fill this column now? We need to know the excitation table of JK flip-flop which we have already discussed in the previous classes. The excitation table for JK flip-flop, if you know, then you can easily fill this transition table. What it is? QN plus 1. For these 2 outputs, we have written 4 possible combination, binary combination 0, 0, 0, 1, 1, 0, 1, 1. When the condition is 0, 0, JK inputs are 0x. For 0, 1, it is 1x. For 1, 0, it is x1. For 1, 1, it is x0. So, it is easy to remember. For 0, 0, 0x, 0, 1, 1x. For 1, 0, x1. For 1, 1, x0. So, let us quickly refer this excitation table to fill this transition table. So, please see what will come. The present state is written as 0, 0, 0, 1, 1, 0, 1, 1. What is the next state of 0, 0? Based on the state diagram we need to write. After 0, 0, what is the next state? 0, 1. So, we will write 0, 1 here. After 0, 1 it is 1, 0. After 1, 0 it is 1, 1. After 1, 1 it is going back to 0, 0. So, like this. Okay. So, after 0, 0, 0, 1, 0, 1, 1, 0, 1, 0, 1, 1, 1, 1, 0, 0. We have written this next state based on the state diagram. Let us now fill this flip-flop inputs. To fill JB, KB, we need to compare QB with QB plus 1. When we find QB and QB plus 1, 0, 0, what is the output coming to be as? What are the J and K inputs? 0x. So, for 0, 0, it is coming to be as 0x. Okay. Now for 0 1 it will be 1x. For 1 1 it will be what? X 0. For 1 0 it will be what? It will be for 1 0 it will be x 1. Okay. So we have filled it as 0x, 1x, x0 and x1 for JB. Now let us fill JA, KA. To fill this JA, KA, we need to compare QA with QA plus 1. So 0, 1, 0, 1. What is 0, 1? 1x. It will be 1x. 1, 0. It will be x1. For 0, 1. It will be for 0, 1. It will be 1x. For 1, 0. It will be x1. So in this way we have filled JA, KA inputs. 1x, x1, 1x, x1. So the transition table is completed. Now let us simplify JB, KB, K maps. K map simplification is the next step. For JB, how many flip-flops we are requiring? 2 flip-flops, JB, KB, another one is JA, KA. So how many K maps we need to solve? One for JB, another for KB, JA, KA. So 4 K maps are to be solved. So which I have, it's a 2 variable K map. So we have drawn 2 variable 4 K maps. These 2 are for this is for JB, KB, JA, KA. For QB, QA. Okay. So now let us fill this column, JB column. This is JB column, no? What is JB coming? It is summation of 1 and is don't care for 2 and 3. Okay. So at 1 this is a K map. We know the cell of numbers 0, 1, 2, 3. So we can easily see this column. For JB it is 0, 1, x, 0, and coming for KB it is x, x, 0, 1. For JA it is 1, x, 1, x. For KA it is x, 1, x, 1. Okay. So see this one. What is K? x1, x1. So we have filled it like this, x1, x1. Okay. So what will be the for grouping for JB now? Let us check me for JB once again. It is what? 0, 1, double x. It is 0, 1, double x. This I have done a mistake. So it is here double x. So here one pair is possible. What is this pair name? It is 1. What is 1 here? QA. So what is JB equal to? QA. What is JB equal to? QA. Now coming to KB, we can form a pair here. What is this one? This is 1. What is 1? QA. So what is KB equal to? KB is equal to QA. Now coming for JA, here one quad is possible. So for one quad, what is JA coming to be as 1, and here also one quad is possible. So this QA will come as 1. So what are the equations we got? JA1, KA1, JB QA and KB QA. Okay, let us now use these equations for drawing the logic diagram. So we require two flip-flops, JA, KA, their outputs are QA, QA bar. Another flip-flop inputs are JB, KB with their outputs QB, QB bar. And the same clock is given to tell that it is a synchronous counter. Bubble is added to both the flip-flops to tell that it is a negatively edge triggered flip-flop. So what are JA and K are connected to? They are connected to 1. So JA, KA are connected to 1. We need to darken this so that we can tell that both JA and KA are connected to 1 and not connected to this clock here. So now JB, KB are connected to QA. So from QA they are connected to JB, KB. Let us darken this to tell that JB, KB are connected to QA. Okay, like this. So we can take the output from QA and QB. So this is a design of synchronous counter which is counting the states 0, 1, 2, 3 and after 3 going back to 0. I hope you have understood the class. If you have any queries, you can post in the comment section. So what are the steps required? First is state diagram, transition table. To fill the transition table, we need the excitation table, then simplification of K-map and finally the logic diagram. I hope you have understood the class. Thank you. Good luck, students.